everyone. Thank you for joining my session today. I'm really excited to be able to talk about the new Domo Jupyter Workspace integration that we have in Domo. And my name is Joe Clark. I am a software architect on the Labs team here at Domo. And this has been this Jupyter integration has been one of the really fun things that we get to work on the Labs project. So I'm excited to share more about it. So some of you probably haven't used Jupyter that much, or maybe haven't used Jupyter within Domo. So I wanted to start out by initially at least talking about the integration that we've had in place for the past couple of years. In the beta program that a lot of you probably have already participated in, some of the use cases that we initially were targeting for that. And so with our initial beta, we knew we weren't necessarily as fully featured as we wanted to be, but we did really have a really good story for pulling data out of Domo, querying data in Domo, and doing some ad hoc analysis on it. Of course, a lot of data scientists also like to use Jupyter notebooks to document their processes. So whether they're doing analysis, whether they're training models, using Markdown as a really good way to ensure that other people can consume their notebooks and reproduce their processes. And then, of course, something that's always really important is making sure that we can write data back into Domo, because that's really where the power of our platform is getting that data into Domo so that we can build cards, dashboards, use that data to drive other processes, Dataflows, alerts, all the cool stuff that Domo is really known for. In this notebook here, just to kind of go over this example, I've actually, this is one that I built quite a while ago when we initially released it. We've got a couple of data sets that I've configured in Domo to have accessible inside of this workspace. These are NHANES data sets, and if you're not familiar with NHANES, it's a data set produced by the CDC, and they go out and they interview a bunch of people throughout the US. These two particular data sets I'm looking at contain body measurement data and demographic data. And so for this first data set, I'm really just looking at the weight right now. For this particular notebook, from the demographic data set, I'm looking at gender and age. And our goal is to do some analysis on how weight changes over time for individuals based on their gender. And so we are going to do some minor modifications, minor transformations here. First of all, we're gonna take our gender column, and instead of having just a 1 and 2, we're going to make a more user-friendly, more readable male and female. And we're also going to assign each individual into an age group. And one thing I skipped here is make sure that we're joining our two data sets on the sequence number, and that uniquely identifies an individual so that we can join our two separate data sets. And lastly, of course, we're going to chart our data. And here we've got our distributions of weight grouped by both gender and age group. And so a lot of our users are doing really cool stuff like that. But there has been some missing functionality in our beta. Like I said before, we knew that there were some limitations. One of those items that people have called out is that the environment's not persistent. So if you install a library that wasn't installed by default, you have to reinstall it. When you start your workspace up the next day. You can't interact with files on disk. We were storing or syncing our files on Domo services. But if you, for example, in this example, if you uploaded a CSV file using the Jupyter UI, you wouldn't be able to then load that CSV file as a data frame in your notebook. And people also having some difficulty, and mostly because of these two items, individuals were having difficulty creating production pipelines. And so We do actually have a lot of users who are using Jupyter as a development environment, so they can develop their machine learning models or develop their pipelines. But because it is in beta and missing some of this functionality, they're turning to other features within Domo for their production pipelines, like, for example, turning their notebook into a scripting tile. But because of the differences in environments, because they couldn't save those model files, sometimes that transition could be a little bit challenging. And so, again, really excited to talk about some of the new features to really solve some of those issues that users are having. First and foremost among those is the ability to create scheduled executions or scheduled notebook executions via Dataflows. And so here we have our Jupyter. Here's that same notebook, my NHANES notebook inside of Jupyter, and we've got a new icon here that looks suspiciously like our Dataflow icon from the Domo UI. And if you click on the Dataflow button, you get this screen where you can create a data flow. You can modify the schedule, so you can either run it manually, you can run it every day on a schedule, or every month, or however frequently you would like, or you can set it to run on a trigger based on the changes to input data sets. And this is a view from the data flow side. So once you've created your data flow using the NHANES notebook, you can see that we have our execution history here. You can click on it. If you get the details, you'll see this view where we have actually saved off the output to your notebook execution and also rendered it as both HTML and PDF. If you do end up needing to edit your data flow, you've also got an Edit in Jupyter button that will take you back to your workspace so you can modify your notebook. So along with that, again, one of the new features that solves one of the problems that was missing from our original beta as this persistent file system. You can upload CSV files. In this case, in this example, I've actually written this this data set from Domo. I've exported the data and I've written it to a CSV file. I can see that it does show up in my file explorer, but we could also do like the previous example, and if we had a CSV file or we have data that isn't in Domo yet and we wanted to just upload it into our notebook directly, we could do that as well and be able to interact with it. This is also really important for machine learning, where if you have maybe one job that creates a model and a separate job that consumes that model, you really need to be able to have that shareable file system, that persistent file system, so that you only have to train your model once, and then you can use it over and over again to make your predictions or your inferences. Along with this, along the same lines, the Conda environment is also persistent and customizable. As has been mentioned, you can right now install, in the current beta, you can install new libraries through Conda, pip, or cran if you're in R, but those are not persistent between sessions. You have to reinstall it. Now with this new integration, the Conda environment is also persistent, so you don't have to continue to reinstall it. And this is also really important from that dev to production transition, because it ensures, again, that your development environment and your production environment are using the exact same Conda environment. And that really helps with that development process. Another new feature we're really excited about is the ability to have control over the number of CPU cores and memory that you have available into your notebook. So if you're doing a really small job that doesn't need a lot of resources, you can be a little bit more efficient that way. But also if you're doing a much larger job with really large data, then we are supporting up to 1 terabyte in system memory and giving you that flexibility to set or have control over your resources for your different types of jobs. A couple of other smaller improvements. We are adding autocomplete directly in the Jupyter environment and also working on Git integration so that you can have better collaboration with your peers. And so that's a good review of some of the new features that we're releasing with this new Jupyter integration. And as I mentioned before, the kind of the target use case for our initial beta was kind of that ad hoc data analysis in Jupyter, and we're really excited about the success some of our customers are having with that. But it really wasn't the end goal. The end goal was end-to-end machine learning and data science processes. And so I wanted to go over a couple of use cases for really showing off that new capability. And as data scientists, sometimes we have trouble maybe producing that actionable content that everyday individuals within our organizations can consume and use to make decisions. And so I really wanted to show how we could get there using scheduled notebook executions. And so for this particular use case, let's say that we are a medical provider that provides COVID-19 testing. And so the first use case that we're going to look at in that process is loading external data into Domo. And why don't we go ahead and take a look at this notebook directly in Jupyter. And here I've got my data import notebook. And I have a data set from Johns Hopkins. They've got an API that they produce. And we're going to go ahead and request this data from their API. Once we have the data, we will load the JSON as a data frame. Let's say we're in California. And so really we're just going to filter that down to California data. And we also noticed that Pandas isn't able to recognize the date column as an actual date time attribute. And so we're going to go ahead and convert our date into a date time type as well before we upload it into Domo. We've got some additional information in there that we don't need, so we're going to filter out just to the relevant columns. And we're also going to add some new information that will help us in our future analyses. So we're going to go ahead and add a couple of columns as well. And once our data is transformed and clean and looks the way that we want it to look, we're going to go ahead and write that data back into Domo. And of course, to leverage our new feature, we're going to go ahead and create a new data flow. Have it schedule once a day so that we know all of our analyses are based on the latest information from Johns Hopkins. And we can also see, once we've executed our notebook, we've got our data set, Johns Hopkins, California data set in Domo. And we can use this data in Domo for all the cool things that we use data for in Domo. Create cards, create alerts, create dashboards. So that's our first use case, is just having yet another way to bring data into Domo, but with the extra flexibility that Jupyter gives us. Next, let's say that as a COVID testing provider, we want to be able to accurately predict whether a customer or a user has COVID-19 or will end up with a positive test result based on the symptoms that they report when they initially signed up to be tested. So let's say we have another data set that contains a set of symptoms. It's labeled, so we also know the ultimate test result as well. Of course, that's going to be needed to be able to train our model. And we're going to install scikit-learn in our notebook. We only, again, have to do this once now. I'll install scikit-learn and use that to train and save our models. And we'll take a look at this notebook here in a second. And we will also schedule our notebook to run once a week, just to make sure that our model is kept up to date. Let's go ahead and take a look at that notebook. So just to go through some of the more detailed information on here, we don't usually want to train on our entire data set in this case because variants seem to come out every so often with COVID-19. We may only want to look at the most recent data so that we're training our models based on the current COVID variant that's in our communities. So we're going to go ahead and filter our training data to just the last month. We're going to go ahead and pull out all of the symptom data from that data set. And we're actually going to use two different algorithms so that we can make sure that our predictions are as accurate as they can be. And this will also allow us to compare a couple of different models. So the first algorithm that we're gonna test is the decision tree, and the second one is the k-nearest neighbors algorithm. And then again, because our environment is now persistent, we can save our models to disk so that we can use them further on in our pipeline. And we can see here in our models directory, we've got our two models that we've trained. And these will be kept up to date every time if we have our execution scheduled to run once per week or once per month, our models will be updated every time we run this training data flow. So here's our next step is, once we have our model trained and ready to go, is to have a notebook that will actually classify our testing encounters or symptoms coming in from customers. So again, we're going to load models from disk. We're going to use those models to classify that data set. And we're also going to do some additional work here so that we can track the model performance and do some other cool stuff in Domo. Why don't we take a look at that notebook as well? So here's where we are loading those models from disk, exporting data from Domo for all of our testing encounters that need to be labeled or that need to have predictions run on them. We're going to add a prediction for both the decision tree and k-nearest neighbors algorithms. And then I mentioned the additional metrics. We want to be able to track the overall accuracy for decision tree and k-nearest neighbors. We also want to be able to track false positive results and false negative results. And so since all of our data eventually is labeled, once we get the results back, we're able to have really, really good metrics as far as performance goes. And so again, after we have our data the way that we want it, our predictions and metrics in place, we're going to go ahead and write this data back into Domo where we can consume it, make sure that we've got our data flow scheduled the way we want it. Right now it's set to manual. We definitely want that on a schedule to make sure that we are classifying that symptom data as it comes in. And so here's the best part about being a Domo customer is that once that data is in Domo, we really get to leverage the power of Domo. Let's go ahead and take a look at this dashboard as well. So here we can actually track our model performance over time as well as compare our two different algorithms. So on the left here, we've got our k-nearest neighbors model performance metrics, and on the right, we've got our decision tree model. And actually, looking at these two charts, they actually look really similar as far as overall accuracy. We've got a little bit of a dip here, probably where we had a surge in cases. Maybe our algorithm isn't as, or our model isn't as good at predicting, where we see those differences. So let's say we did want to create an alert if our overall accuracy went below a certain amount. So it's at 97 right now, or 97% right now. We could easily set up an alert that just said, hey, if our summary number goes below 90%, then we want to set up an alert. So I'm not going to go ahead and actually create that right now, but very easy to do. And looking at some of our other metrics here, even though the overall accuracy was the same, we can see that the false positive rate for decision tree was much higher than for k-nearest neighbors, and there was a smaller difference on the false negative rate. And so even though the overall accuracy didn't help us choose between the two models, we may choose to go with k-nearest neighbors simply because there is a much lower false positive rate. And so another use case, let's say we're still acting as a medical provider. Not only do we want to be able to predict whether or not an individual has COVID-19 based on the symptoms that they're exhibiting or that they're reporting, but we also want to make staffing decisions at our individual testing locations based on estimated demand. And so we're going to go ahead and create another notebook that will help us with that. Here's our forecasting notebook. And so we've installed Profit in our environment, Meta's open source library. And we're going to go ahead and query data from Domo. This time we're going to do some aggregations to make sure that our data is in the format that we need to make our predictions. So now we have total tests per day over time. We're going to go ahead and fit that data to make our predictions, and we're going to go ahead and predict 180 days in the future. And here we see our trend line has been steadily increasing. Here's where we start making predictions in our upper and lower bound. And probably more importantly for our current use case is that we have per day estimates where, hey, Monday you're probably going to see more testing than on Wednesday or Thursday, where you might see fewer individuals come through. So once we've got our prediction data, again, we're going to write this back to Domo, schedule our data flow to run. Once we've got that data flow running, we'll be able to ensure that we've got this updated data in Domo as frequently as we need. And so another use case that we can use schedule notebooks for is to run our analyses on a schedule. Let's say we wanted that notebook to generate a PDF report that we could share once a week. We can do that by going to the execution details and downloading that every time that it runs. But again, really the power of Domo comes to play when we get the data into Domo and we really get these interactive dashboards. Let's go ahead and take a look at this dashboard. And here again, we've got our trend line. And we've got our upper and lower bounds and our estimate trend. But because we've got that data in Domo, we can also come up with some really actionable information if we are wanting to make those staffing decisions on a day-to-day basis, where we can see that, hey, the next 5 days this week, or at least the last time it was run, we want to show what the forecasted demand for testing is at your location, and the manager at that location would be able to assign more or fewer employees to work on that day. Thanks, everyone. We're really excited to be able to share all this hard work with you, and we're looking forward for your feedback.